Okay, so some old ways that oxidation and reduction were defined was based on oxygen and hydrogen. So oxidation was defined as the gain of oxygen, or it was also defined as the removal or loss of hydrogen. And you have two examples there. Magnesium is being bonded with the oxygen, so it has gained an oxygen. So we would say magnesium was oxidized. The ethanol has lost a hydrogen. It went from 5 to 4 hydrogens. So it lost this one hydrogen there. And we would say that it was oxidized. Reduction is the gain of hydrogen, or it could be looked at as the loss of oxygen. And then there's two examples for you. These are the old ways of viewing oxidation and reduction. I have seen some questions referring to these old terms, so make sure you know them. However, we are not going to look at it in terms of oxygen and hydrogen, because hopefully you know that not all reactions have oxygen and hydrogen in them. Instead, we're going to look at what's happening with the electrons themselves. So we say oxidation is the removal or loss of electrons. And oil is one way of remembering that. So you have oxidation is losing, and then reduction is the gain of electrons. So reduction is gaining. So if you remember oil, you can remember that. Another way to remember it is Leo the lion goes grr. So you have lose electrons oxidation, gain electron reduction. So there's two ways for you to remember the definition of oxidation reduction in terms of electrons. I personally prefer oil rig. Redox is when those two things are happening at the same time. So what happens is the electrons that are lost in oxidation are the ones that are gained in reduction. So that's why they happen in pairs. There's always one oxidation and one reduction. And then some terminology that gets some students: oxidizing agent and reducing agent. Oxidizing agent is the thing that is causing oxidation to occur. So it itself is reduced. And then the reducing agent is a substance that causes reduction to occur, but it itself is being oxidized. So the way to look at that is agent means it's doing it itself is the opposite, or it's causing this to happen, therefore it's the opposite happening to itself. It gets a little confusing. So let's look at two examples. We want to identify the oxidation and reduction half reaction, the oxidizing agent, and the reducing agent. So the first thing that you want to do is figure out the oxidation states for all of the elements that are in the reaction on the reactant and the product side. So for dichromate, we know oxygen is going to be a -2. There are 7 of those, so that's -14. We need a -2 to be left over, so chromium then has to provide a +12. There's 2 of them, so each one is going to be a +6. Hydrogen is an ion here, so its charge is its oxidation number. Same thing with the iron. Same thing with this chromium and this iron. And then in water, oxygen is a -2. There's only 1 of those, so we need hydrogen to be +2 total, so each one is going to be +1. So make sure you can write the oxidation numbers. This is why we practiced. And then you have to figure out which elements changed. Now there should only be 2 elements whose oxidation numbers changed throughout the reaction. So oxygen we can see is a -2 on the reactant side, but it remained a -2 on the product side. So it is not the element that's being oxidized or reduced. However, we can see chromium is going from a +6 to a +3. Therefore, chromium's oxidation number is changing. So if we look at that, we can see that the oxidation number goes from a +6 down to a plus 3, so it's being decreased. So the oxidation number is going down, which means we gained electrons. So this is reduced. So my reduction half reaction would be Cr2O7 2 minus going to 2 Cr3 plus. Don't worry about the balancing part. We will get to that in our next lesson. So then we find the other one that changed was our iron. The iron went from plus 2 to plus 3. So the oxidation number increased, which means it lost electrons because electrons are negative. So it's going to lose electrons and become more positive. So lose electrons is oxidation. So this is my oxidation half reaction, and we would write Fe2 plus, you could write 6 of those, go to 6 Fe3 plus. Again, don't worry about the balancing part because we will get to that in our next lesson. So there's our two half reactions, and then we want to know the oxidizing agent and the reducing agent. So remember, the oxidizing agent is the substance that's causing oxidation to occur. So the oxidizing agent in this case would be the dichromate ion because it was reduced, so it's causing oxidation to take place. And then the reducing agent is the thing that causes oxidation to occur, or causes reduction to occur, sorry. So it itself is being oxidized. So that would be our Fe+2 ion. Notice that the agents should always be reactants in the problem. All right, let's look at one more example. Maybe pause and try it on your own. The first thing that you want to do is put oxidation numbers for all elements involved on the reactant and product side. So oxygen is a -2. There's 4 of those, so that's a -8. We want one negative to be left over, so manganate is going to be a +7 here. Oxygen is a -2. There's 4 of those, so that's a -8. We want 2 negatives left over, so carbon is going to have to be a +6. That means each one is a +3. Hydrogen is an ion here, so its charge is the oxidation number. Manganese, the charge is the oxidation number. Carbon dioxide, oxygen would be -2. That's a total of -4. So carbon will have to be a +4 to make that neutral. And then in water, oxygen is a -2. Each of our hydrogens then is a +1 to make that neutral. So once you have your oxidation numbers, look for the 2 elements that are changing, and there should always be just 2 elements changing. So if you have more than 2 changing, something's wrong with your oxidation numbers. And if you don't have 2 changing, then you either did the problem incorrectly, so something's wrong with an oxidation number, or this is not a redox reaction. All right, so the 2 that are changing then would be our manganese, going from a +7 to a +2. So the oxidation number has gone down, which means it must have gained electrons, because electrons are negative, so the more you have, the less positive you become. And when you gain electrons, oil rig is reduction. So our reduction half reaction would be MnO4 minus goes to Mn2 plus. If you want to put the coefficients there, you can, but again, we're not worried about balancing at this moment, so it doesn't matter. And then the other element that changed was our carbon, that went from a +3 to a +4. So the oxidation number went up, and in order for it to go up, that means it must have lost electrons. So this is oxidation because of oil. Oxidation is losing. So my oxidation half reaction then would be C2O4 2 minus, or the oxalate ion goes to carbon dioxide. Again, since we're not balancing, the coefficients don't really matter. We will be looking at balancing in our next lesson. And then we need to do the two agents. So the oxidizing agent causes a substance to be oxidized, so it itself is reduced. And so that's going to be our manganate ion, MnO4 minus permanganate. And then the reducing agent is causing reduction to occur, so it itself is oxidized, so that would be our oxalate ion, C2O4 2 minus. All right, make sure you fill out the Google form so that you can get credit for watching the lesson, and leave any questions that you have, and try the problems in the textbook, and we will of course go over those.